Okay, so we're still looking at similar triangles now, but now we're going to have some more application questions. So you'll see sort of the worded questions, or they might not tell you that they're similar triangles. You need to work out that they're similar triangles. So remember, similar means that they either have, we have a few reasons they can be similar. They might all have the same angle. So here we can see these two triangles have all the same angles. That would make them similar. Now, another thing could make them similar if their sides are in the same ratio. And what we mean by that is if they've gone up by or down by the same amount. So this 4, if you times 4 by 2.5, you get 10. If you times 3 by 2.5, oh well, it doesn't actually have that side. That would be this side over here. Yeah? Okay? So what we're going to find here in this example is that they're saying, we know they're similar because all the angles are the same. So we already know. We can say they're similar. So if I was trying to find out what this side I've labelled X is, because I've got the 3, well, I can see, I know that 4 was times by 2.5, so I could times 3 by 2.5, and that will tell me that this side over here would be 7.5. So we'll look at finding unknown sides and things like that in our applications. So just remember, if you're multiplying, so see how this triangle went up by 2.5, that is actually the scale factor, yeah? So that's what we call the scale factor. The amount that you times it by is actually the scale factor. All right, so let's have a look. So give reasons why these pairs of triangles in each diagram are similar. So we're just looking at this one. This is just this triangle. So we've got, I'm going to draw them out separate. So we've got the big green triangle in this diagram, and then we have this blue one in here, the smaller blue one. Okay, so we know that they've both got a 90 degrees, haven't they? Yeah? So that is. Now, can you see, if I put a circle, they both have that angle, don't they? Yes? So if two angles are the same, the final one must be the same, isn't it? Because you do 180 minus the other two, they're going to be exactly the same, aren't they? So these two triangles are similar because of angle, angle, angle. Can you see that? Yeah. So in this diagram, we've got these parallel lines, which we did earlier in our unit. So we've got parallel lines, and do you remember, if you have an intersecting line, remember alternate angles are equal, yeah? So that angle is equal to that angle. Remember alternate lines? So if we had like this, we said that is equal to that, yeah? So I'm saying there's the line, I'm saying this little angle is equal to that little angle in there, okay? So if you look now, if I draw my triangles out, I've got this big triangle here, which I'll redraw for you. So I've got the big one, and I've drawn a dot there and a circle there. I know those angles. Now I've got this little one down here. Now I'm going to turn it upside down so you can see. Well, if I flip it over, I could draw it out where it has the dot and the circle, doesn't it, on the parallel line. So if there's two angles that are the same, are they going to be similar? Yeah, so we know that they're similar. All right, so let's have a look at some questions that we are going to get. So for the pair of triangles given in the diagram, which reason would be chosen to explain why they're similar? So let's get the two triangles out. So we've got this big triangle here. So I'm going to redraw it again. I've got the big green one. on the outside, so I've got parallel lines. Now this, if I call it A, D, E, so this would be a 6, wouldn't it? Yeah? And this is a 6 because I've added these two together. Now I'm going to say that it's similar to this little one, the blue one. So I'll draw that one too. So draw the blue one, and it's A, B, and C. Okay, so we have these parallel lines again, and you have an intersecting line in there. So if you've got parallel lines and this intersecting, that makes this angle, these are what we say as, what do we call them when they're in the same? Corresponding. Do you remember that? They're in the same spot in the pattern. So corresponding angles are equal. So that means I know that that's in there and that's in there. Now, don't they both share this one? Do they both share that one? Yeah, they do. And we've also got, sorry, I could have put this one's 3, isn't it? Yeah? So I could say, I know that they are equal. I'm going to say because of angle, angle, angle. We've only got one side, so let's just say angle, angle, angle. But what is the scale factor? Now that we know that they are, so what can we say? What has happened when it went that way? It's divided by 2, isn't it? What would you times something to get it to divide by 2? You times it by a half. Does that make sense? Yeah? So we could say, it depends which way you're moving. You could say the scale factor is a half if you went from large to small. If I was going small to big, the scale factor would be 2. So it'd be double, wouldn't it? It depends which way we're going. So we'll just say half that way. If we're going that way, we'll say 2. Okay? So maybe we'll just write that. That's our scale factor. And that's our scale factor that way. Okay. So if we know what is the length of BC, so if we go, what's the length of BC then? They're talking about this side along here, the BC. We know we halve it, don't we? We halve the big one. So it'll be 3 too, won't it? So BC, sometimes they write BC like that, the line BC equals 3. And you've done, okay? All right, so we've got a homemade raft consists of 2 sails with measurements as shown, and the angles are shown in the diagram. Give reason why the 2 sails are similar in shape. So we can see here they've both got a 90 degrees, and they're both saying that this angle is the same. When you put 2 dots there, you can say they're saying they're the same. So if that's the same, then we know that angle up there is also the same. So why are we going to say the 2 sails? We can say angle, angle, angle. There could be more than one reason, but let's just go with that. We can see they're all the same. All right, what is the scale factor? So let's go from the green triangle. We'll pretend we're going to the green up to the blue one. Okay, so the blue one, if I put the right angle and that dot is 5 meters, and if I put the right angle and that one, that dot, it's 2 meters, and they're saying this is 3.5. So what did they times it by? 2 times what gives 5? 2.5. Yeah, so times it by 2.5. What we can always do, if you want to check it, you can just go 5 divided by 2. Remember like what we were doing yesterday and we work it out? So we know it's 2.5. So if you want to work that out, I'll just write in brackets, it was 5 divided by 2 equals 2.5. That's how you worked out how it went up. Okay, so that means that's the scale factor. So we might just write scale factor equals 2.5. So therefore, find the length of the large sail. So they want to find this. So therefore, x will equal the 3.5 times the scale factor. Yeah? So this is timesing by the scale factor. So what does 3.5 times 2.5 equal? Okay, so it's 8.75. So maybe you just write the sail, or the large sail, equals 8.75 meters. Okay, awesome. A vertical tent pole is held in place by two guy ropes. So guy ropes are that's what you call a rope that connects to a tent. They're actually called guy ropes. So these two things, they are calling guy ropes, okay? Just so you know, all right? And then they've said that they've got a vertical tent pole. So that's that vertical tent pole there, okay? Give reason why the two triangles formed are similar. So let's have a look. Now, if you look over here, this is also a right angle, isn't it? Yeah? So if I draw them out, like I draw the big one, so the big one has 1.2 meters and it has this angle here. And the little one, if I turn the little one around to face the same way, so I have a right angle and I also have that angle the same there, and they're saying that's 0.6. So I can say they're similar because if we have two angles that are same, it means the third one must be the same as well. So why are they similar? Angle, angle, angle. All right, now we have to, we also know this little length. They've given us this, the 0.8 meters, and it's saying find the height of the tent pole. So this is the tent pole. I'll just call it T. Okay, so you can actually do it like what you were doing yesterday. So say we called this one the original and this the copy. So remember, as long as you get the same side. So I could say, remember, and I said just do original over copy. If they're similar, their ratios should equal each other. So I can say 1.2 over 0.6 should equal the T over the 0.8. So can you see that the original, these two things come from our original shape, don't they? And the copy, these two pieces of information came from our copy. Okay, so then once you've got that, you can actually just use your solve if you like. So we can go solve 1.2 over 0.6 equals T over 0.8, comma T. So when you don't have to sort of say the scale factor, we can just solve it like that. Oh, they did want the scale factor. Sorry, I missed that. So if we go from, it depends which way we go. If we go from the big one to the small one, it looks like it's halved, isn't it? So we'd say a scale factor of a half. That's why I don't really like these questions, because they're not saying which one is which way are we going, yeah? If we went that way, the scale factor would be timesing by 2. So you guys, just when they ask you that, put both ways and then you'll think. So what was our tent pole? Did anyone solve it? All right, so we get the tent to be 1.6. So today you got to do exercise 7G and you're working through questions 3 to 7. Okay, they may